Okay. Now, if this is true, what I have said in this lesson, we formulate the new problem. Problem is prove second or over root formulation for a x square b x plus c equals 0 in terms of the what? Geometry or geometric axis. Okay, and we will give the solution in here. So we can write this term ax bx plus c is equal to 0, and then we can define the two axes right now. Okay, x and x, right? This must be contained in the what? In two axes, because this is the common variable for representing these two terms, right? And so if we have two roots, and so we have the area in here. If we have the three roots, and then we will have to what? Volume. Okay, we can write it. And so what's the area of this term? What? X square, right? This is the x square. And so if we have this information, and then we can convert this equation just like this one, a bax plus ca is equal to 0, right? And so this x square must be equal to the what? The bax minus ca, right? This is the first equation, right? And so how can we derive the any other terms in here? Because it's an area form, and it must be an area form, right? These two terms represent to what? To area, right? And so we have the x square like this one, x square, and so we have also a bax and ca, and so this must be another area in this form. Okay, so how can we do that? We can split this term into the two parts. Okay, 1 divided by 2 bax plus 1 divided by 2 ba times x. Okay, we can write it, right? And so if we have this information, and then we can continue with this definition, x square xx, and so we can also give the two area in here with the what? With these coefficients. One divided by 2 ba, 1 divided by 2 ba, right? We can write it. We can add the abstract area in here. And so if we multiply with the x and this one, and 1 divided by 2 b divided by a times x, and 1 divided by 2 ba times x, right? And so this area can be completed with the what? With these two terms, right? We have one area, two area creates to what? The ba times x, right? It's the proof. And so what about that? We must contain to the what? Or we must complete this square, because if we have this information here, and then we need to provide another square in here, because we have the what? The two roots. And also we have the area in here. Okay? And so, if this is the case, and then just see that this line, and I can write this term in here like this one, x just like this one, x square x 1 divided by 2 b divided by a, 1 divided by 2 b divided by a, and so divided by ba times x, 1 divided by 2 b a x. Okay, and so this is the question mark. Okay, and so if we take the square of this term gives the complete area of this term, right? Okay, and so x square b a x, because it's multiplication of term, and then we have the 1 divided by 2 b a square, right? This is the formulation of these terms, and so we have this term and we have also this term, and so this must be equal to the what? CA, right? Do you get it? This formation, this simple area equalization of the what? These terms, right? Okay. And so, if this is the case, and then we will write it down like the x plus 1 divided by 2 a square plus minus ca plus 1 divided by 2 b a square, right? Because this minus ca must be equal to this one, right? Because in the second example we can write it just like that. Okay, because this ca gives to the what in here x square b plus bax, which is equal to the ca, right? If we put this equation, this coming from the what? Ax square plus bx plus c 0. And then if we are using this term, and this term removes the whole the parts, and we can assign to what? The roots of these terms, right? We can assign it. Ca can be written into this form. And after that, if we know this information, and then we're taking the square root of this term, ba is equal to the what? This term minus ca plus 1 divided by b square a square, right? And after that we can say this term okay, square, right? And so x is equal to the what? Minus 1 divided by 2 ba plus minus ca plus 1 divided by 2 ba square, right? And so if we rearrange the whole equation, and then this gives us minus b divided by 2a and plus b square minus 4ca. This is the definition of the r root in here. Okay, and so this proves that we have the geometric information, and so we can find a root to complete some general square form in here based on the area. And so the Pythagorean theorem corrects to the what? To this information, right? We can find the roots using only the geometry to complete the whole square form, right? Do you understand this information? And so we can derive the second root or the two roots based on what the geometrical information, and so this x can be manipulated to complete this formation in here. And so if we assign to these values, the root values in here, like this one, and then we will have the this x value or the x-axis in here. If I use the three roots in here, and so we can assign everything in the volume formations. This is the area form, but we can obtain to the the over 3 formation or the volume formation in that case. Okay, we completely created the two roots based on these informations. This proves that the algebra and geometry can relate to each other. Okay, and so this is the abstract feature or the dimensions or the independent features of the these equations. Okay, but not just in algebra form, but also in geometric one. Okay, and so these are roots, and so we have two conclusions in here. The geometry can be explained with the algebraic calculations, and secondly, area gives an inequality resulting the roots its own axis. For example, if we have the one direction here, like this one, x1, and the other term gives the x2. This completes the whole the axis formation based on the area formation. And so this x1 can be converted to the x2. x2 can be converted to x1, but with for a complete square form in here, right? We can convert two things into another one. And so the other conclusion comes with the another formula. What is the infinite roots? It's just kind of the x1, x2, x3, xn, and n goes to infinity, or the infinite roots fx is equal to the x0, a x1, b x2, and blah 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 blah, and z, for example, xn goes on these terms. Okay, and so these roots define a system, but unknown system. But we can match this system, or we can represent this system in terms of the adding or multiplying the 1x value in here. Just remember that we can expand to the functions or the signals or the variables to the Taylor expansion, right? What is Taylor expansion? Anyone knows Taylor expansion? Just check it on the internet in the next lesson, okay? And so we can define the infinite root, but we may have also a different way to define these roots, the infinite roots or frequency roots, because we have these kind of signals like this one goes and goes on. And so how many roots are contained in this signal? At every iteration, one root, second, 3, 4, 5, 6, 7, 8, 9, 10, and blah blah blah. Until the apocalypse, we will have roots, right? And so if the roots are the independent feature, and so the time maybe have an independent features, right? Which we call it frequency. You get it? If the roots are the independent feature of something in universe, and the time may have also independent features, just like the frequency. Maybe we can convert the frequency to the time to frequency, right? The Heisenberg can do that in physical domain. The momentum and position can be related to each other in the energy forms. But in the signals, we have the abstract notions. And we can relate, or if we define the time in mathematical concepts, so we can use this nomination because the time is coming from this notion, right? And what is time for a system? Time has the infinite roots, right? And so we can represent the infinite roots in one way by using the infinite roots, or another definition which we'll call it two frequency. Okay? Because we prove it. We have proven that everything that the algebra can be represented by the geometry, or the geometry represented by the algebra, right? Otherwise, we don't have any root values in here, right? But this shows us this nomination, and so these independent features, and we can select the B, A, C as a different values to what? To represent the another features. For example, what's your name? Ali. We can represent the Ali using just this equation. With the what? With the different coefficients A, B, C, right? But what's the main or the common parts of this equation? These equations have always a root to define itself. In static or the dynamic formulation, it's dynamic directly related to time, but we can also offer the static equations like this one. We need two roots to define this structure. The roots are everything for in math, because the roots engage with the geometry or the axis in physical worlds. Just remember that. Have you ever taken the artificial intelligence course? Just see that if we have the input values like this one, the length of mass, and so we can classify these informations with the what? With the based on the mass and length, right? Right? And so what is mass in here? Just say it. Root. But it's our root. We can define it in neural network, because the neural network can think in theory, in assumption. We can train it, but with our basic concepts. But in universe, we have the basic rules, just like the Newton's law or Kirchhoff's law or the electromagnetic theory. Okay? And so this always present in the universe. But in neural network or artificial intelligence application, we can assign the axis in here. And so we can find the specific roots by training the neural network. Right? But where does it come from? It's coming from to the what? Pythagorean theorem. Everything about the math is a result of the application of the Pythagorean theorem to any theory. Just remember that. It's our father for scientific knowledge. We can always use, but we don't know how it's going on in these scientific concepts. If we can draw this line because the Pythagorean theorem exists. Just you don't know anything about it, but always use it. Okay? We always taking a derivative. Just like this one. For example, if we have the t and xt, right? And so, if you take the derivative of these terms, actually, we draw a Pythagorean triangle, like this one, right? Delta t, delta x, and so x dot is simply equals to what? Delta x and delta t. But this is just Pythagorean triangle. We can relate the time with the x. If there's no Pythagorean triangle in here, and so we cannot derive any other dimensions, or we cannot directly relate or engage any dimension to another one. This is the basis of everything. And if we have the 90 degrees of these terms, which we call it the orthogonality. Have you heard of it? And so at every filter, we use the orthogonal properties. Or in control system or system dynamics, we will use every time to the orthogonality, which is coming from the what? Pythagorean. Okay? Have you understood everything that I'm saying in here? It's a philosophical thinking. You cannot easily find this information on the internet or any other sources. Any question? Yes?
Hocam şimdi bu frekans için sonsuz dedik ya, sonsuz. Yani bu sonsuz özelliği mi var?
Yes. I will prove it. That's why I'm here. To prove it. I'm paid for it. Okay? Any question? If there is no question, next week we will drive the imaginary components based on the roots. What's the j or I value? Just like this one. Anyone knows this formulation? Just like 1 plus 1 dot j. But what is this? What is that? We don't know, right? But based on this information and roots, we will prove it in the next week. Okay? Yes. Yes. Yes, but where is it coming from? Why should we equal to the square form sqrt minus 1? Why is that? Why j, which is equal to the minus 1? This is the results of the what? The optimization of the dynamicity with respect to the time. And so it should be equal to the minus 1. Hı-hı.
Ve oradaki şey, Pythagorean şeyi
Hı-hı.
bunun düşmesini zaten eksiye geliyor ama biraz.
Yes, but we should explain everything based on what? The physical facts and the mathematical facts. Okay? In the next week, we will talk about it. And after that, this J represents to the what? The frequency feature. And then we will drive the Euler identity. And after that, we will prove the Fourier transform integral based on these informations. Okay? If there is no question, and then I will end this lesson. Okay? Okay. Yes. Hı hı. Yes. In the real and imaginary part, your question is that we have this real and im. Is that right? It's your question? Mm-hmm. Uh-huh. Yes, you will be a great guy at that day because before you, the Newton did that. Yes? Yes, but just try it, okay? I will applaud you about that, okay? But in the state-of-the-art application, we just focus on the neural network or the generative network applications because we don't have any roots or the features right now. If we have this structure based on the neural network, and then we can add the infinite roots or the many other roots to our system and we can train it. But at the previous age, we don't have such kind of informations or the mechanism just like that. And so the Newton should try to find out to these formulations. But what happened if the scientist cannot discover these features, the Newton's law or the physical law, and then maybe today we will create the everything based on the neural network, taking the samples from everything, okay? Because we don't know anything about the quantum mechanics right now. But at every time we try to build a model based on the AI to represent the probability and its mechanism of this quantum mechanics, right? But just like Ali, maybe, he creates the quantum Pythagorean theorem, right? Just like this one. But you need to understand that everything is coming from this triangle or the combination of the geometry and the algebra. And if you want to try to build a complex or the simple model to explain everything, and then you should prove it just like this one, okay? In algebra and the math, okay? This is the simple Euclid space in here, okay? The 3D. But the Hilbert defines the n-dimensional space after discovering this formation. And then the Fourier creates the frequency concept based on these informations. Okay? Any question? Okay. So, we will see in the next week. Have a good day, guys.